All right, we're going to talk today about something you guys have probably heard of before, and that is measures of central tendency. But before we get into the notes, just a reminder, there is no daily quiz today, and there is a Math Excel due tonight. So try to get that Math Excel done if you haven't done it yet. So let's talk a little bit about measures of central tendency. So if you think about measures of central tendency, that's any way to find the middle of your data set. We actually have a couple of ways to find the middle of our data set. Most often we use the mean to find the middle, and that is really helpful if you have a good quality set of data. We'll talk about what would make it not quality in a minute. But if you have a good quality set of data, the mean is a great measure of central tendency or a great measure of where the middle of your data is. The mean is the average. So to find the average, you're going to add all of your data together and divide by the total number of data values you have. So you can see in our example here, I have 3 data values, add them all together, divide by 3, and that gives me my mean over here. When you find your test grades or, for example, in our usual grading system, then a lot of people would use the average to help them find the middle of those data numbers. The next set of data is, or the next middle that you can find is the median. And the median is going to be the middle number if you put them in order from least to greatest. Sometimes the median is more helpful if you have that weird set of data, and I'll talk about again what makes a weird set of data in a second. But the median can be also helpful in addition to the mean. Don't forget, you need to put them in order and then find the middle of that data. And usually, if there's an even number of data points, the middle is really between two numbers. So you'll have to find the average of that. If you have an odd number of data points, for example, 7, then there will be an exact middle number and you'll be able to just go through and find that number. So if this is my data set here, to find the median, first I need to put it in order, so smallest to largest. And then I like to go through and just cross out first, last, second, second to last until I get to the middle. If you have two numbers in the middle, then you'll have to find the mean of that. So in this group, there was an even number of data points. So I took my 7 and my 9 and found the mean of that. 7 plus 9 divided by 2 is 8. So that gives me a median of 8 for this data set. Again, if there was an odd set, then there would be exactly one number in the middle. So mean is for a really nice set of data. Median is for kind of a wonky set of data or just another middle number that you need. The third middle number we're going to talk about is the mode, and that's your most frequently occurring value. Mode is not exactly helpful for finding the middle, but it is helpful to tell us how many times something occurs. You can have multiple modes, you can have no modes. So, mode is kind of an interesting thing. You're just looking at your data sets and finding out which numbers occur the most times. You would have multiple modes if they occurred the most times the same amount. So in my data example for the mode, you'll see I have 2 7s and 2 11s. That means they both occur the most at 2. So I have two modes of 7 and 11. If you have two modes, we call that bimodal data. So making sure that you look at that and see if you have bimodal data for two modes. So if you remember, we talked about mean and median, and I said one would be a good set of data and one would be a not so good set of data. So how do we know if something's a good set of data? Well, we need to look and see if it has an outlier. So if you have an outlier in your data set, which would be one data point that is substantially high or substantially low compared to the other numbers, then you might want to go with your median as opposed to your mean because your mean will be thrown off. Think about it this way. If you get one really high test or one really low test, that's going to change your average test score quite a bit. So in that case, if you want a more accurate measure of your test performance, you might find the median of those test numbers instead of the mean to not be swayed by that one really high or one really low test. You can see in my data here, I have a whole bunch of numbers that are pretty low, single digit numbers, And then I have 78 as clearly an outlier. It is much higher than the other numbers. So that's all our middle numbers. If you want to talk about how spread out your data is, which does tell us quite a few things, then we're going to take a look at the range. And the range is the difference between your greatest and least values. So I have a little data set there. The greatest number is 27, smallest number is 3. Find the difference between those, and I get a range of 24. So that tells us how far apart our data values are. Sometimes we want a big range, and sometimes we don't want a big range. The other thing we try to look at is each quartile of our data set. So quarter is 4, right? There are 4 quarters in a dollar. So quartile means we want 4 groups for our data set. You go through and find each quartile by finding the median of the whole data set and then finding another median for the first half and another median for the third half. So if I go back to that data set I started with, 2, 6, 7, 9, 13, 21, we found our median, which was 8 way back on earlier in the notes. So you'll see my green line there to represent my 8, which is my median. And then if I look at my left side, that's the 2, 6, 7 group. So the median of that group would be 6. So that's where my first quartile is. And then 9, 13, 21, the middle number there is 13. So that would be my third quartile. And that just kind of divides my data into 4 parts. Before the 6, between the 6 and the 8, between the 8 and the 13, and then after the 13. So that would be our 4 groups. Also, we like to look at that interquartile range. That's going to give us another sense of how spread out our value numbers are. So if we look at our interquartile range for this one, we have a third quartile of 13 and a first quartile of 6. So if you subtract those, then you get a total of, or interquartile range of 7. So one of the other things you can do with your data set is make a box and whisker plot. We are not actually going to make box and whisker plots, but I wanted to make sure you saw them and knew where to find those quartiles on there. You could have to look at a box and whisker plot in the future. So just kind of knowing what it looks like and what it does is pretty much all we want to do. So if you're looking at your box and whisker plots, obviously we have 2 boxes here, and then we have 2 whiskers, that's each side. The minimum number or the smallest number in our data set is at the very end of the whisker in the front. The largest number is at the very end of the whisker in the back, so you can kind of estimate those. So this minimum would probably be like 55 or 56, so in the middle between 50 and 60. So the minimum here would probably be 55 or 56. The maximum here would be 85, 86, somewhere over there. You can go through and find the median of the data. That's going to be right here in the middle of the 2 boxes. So somewhere around 72, 73. And then you can find the middle of your data first, or the middle of the first half, and that's your first quartile, and the middle of your second half, that's your third quartile. So you could estimate those as well, somewhere around 61 and 82. So you could get a good set of data points from that box and whisker plot as long as you know where each of the parts are. So minimums at the beginning, first line for the box is quartile 1, middle line in the box is the median or quartile 2, third line in the box is quartile 3, and then at the very end of that last whisker is your maximum. Looking at one and estimating some data from it would be about all we're going to do with our box and whisker plots. We are not going to make them ourselves. Last up, we're going to talk about percentiles. Percentile is a number from 0 to 100 that you can use to evaluate a data set. You might have heard this in some kind of standardized testing. They do it a lot for my kids when they go for their regular doctor checkups. They say they're in such and such a percentile for their height or such and such a percentile for their weight. And it just kind of gives you an idea of how, where they stand among an average 100 kids. So if they were to say, oh, they're in the, 56th percentile for height, then I know they're pretty much average because they are taller than 56% of those kids their age. And you'll see a percentile question here in a minute. All right, let's talk about our practice problems. So in the first one, we have a set of data, and we have to go through and find the mean, median, and mode for each of those data. Now, the hard part about this particular problem is it doesn't give you all the data. It kind of tells you how much of each data there is, and you have to turn that into a string of data sets. So the number of students who got that many job offers, which means there are two students or two data sets that both got 0 job offers. Two students that got 1 job offer, so there should be 2 ones. 4 students that got 2 job offers, so there should be 4 data points with a 2 on them, etc. So that's the first thing I did was fill out all of those data sets from this table as individual data points. Mean, add them all up together from 0 to 4, and then divide by the total number. There's actually 15 numbers there, so my mean is 2.2. For my median, I went through and lined them all up. Luckily, I wrote them all in order already. Went through first, last, second, second to last, third, third to last, etc. Started crossing them out until I got to the middle, and in the middle here, that was 2. Notice our median and our mean are pretty close together, and that makes sense because our data is not really, doesn't really have any outliers. There's nothing really high or really low there. So the mean and median probably would be pretty close together. As for mode, the number 3 occurs the most times. That means 3 is the mode here. So there's your mean, median, mode. All right, if we go down to problem number 2, talking about our outliers, the first thing I did was write all of our numbers in order, so from smallest to largest. And then I tried to look and say, okay, what are the numbers, kind of close to? Most of the numbers are 50 or 60 or kind of close to 60-ish. 98 then would be the exception. It's really far away. That means 98 is my outlier. So then problem 3 asked me to compare two sets of data. Whenever you're going to compare, you need to gather as much information you can about each data set. So I took each of the strings from St. Petersburg and Key West, and I found all of the different things that I could find. Mean, median, mode, range, quartiles, first and second, and interquartile range. Sorry, first and third quartiles and interquartile range. So you'll see in each of these little groups here in just one second. There we go. That I found all of that information for each of those. Remember the mean, added all the numbers together, divide by 12 because there's 12 data points. Median, smallest to largest, crossed them out. Mode, how often do something occur? Range, of course, the biggest number from the smallest number. To find my first quartile and my third quartile, remember when they're in order again, I'm finding the first quartile is the middle of the left group of data from that 76 median. And then 84 would be the middle number from the right group of data. Subtract those two and you get an interquartile range of 18. Same thing over here, divide by 12 for my mean, put them in order for my median and for my quartiles, subtract the largest from the smallest for the range, etc., etc. Okay. So from that, you can gather a couple pieces of information. So notice that our ranges and interquartile ranges, these numbers for St. Petersburg are much larger than these numbers for Key West, which means Key West is probably more consistent and it's the same type of number or temperature all the time, where St. Petersburg is a bigger fluctuation of temperatures. Some are higher, some are way lower. Also, if you notice, the median and mean are both higher in Key West than they are in St. Petersburg. So, in general, we're looking at Key West to be the warmer and more consistent time or place. All right. Last up, let's talk about finding percentiles. So they want to know which value is at the 65th percentile. So first we have to find out how many data points are at the 65th percentile. So I count through my list and I find out there's 20 data points. So I need to find out which percentage is 65th percentile. So I do 20 times 0.65. Remember, that's a percent changed to a decimal. And I find out the number there is 13. That means that 13 values are at or below the 65th percentile. So they fall from 0% to 65%. So if you look at my list, all the numbers that I crossed out are all in the lower group, less than 65%. Everything that's not crossed out is above 65%. And then I just counted up to 13 numbers, and the 13th number was 82. That means my 82 is the value at the 65th percentile. All right, there is optional practice for 11.6, and if you needed practice on last class's lesson, 11 optional practice on 11.4, there's that in your OneNote notebook as well. It's all optional, not graded. Don't forget to email me or Teams chat if you have questions, and office hours are on Wednesday if you'd like to join.